Let's talk now about monopoly and market power. So we've thought about perfect competition, where we've got lots of firms, each of which is small compared to the size of the market. They're all selling an identical product, and that means that none of the firms have any market power. They are all price takers. So now let's think about what happens with the other end of the spectrum, and that is monopoly. And this, of course, is a situation where there's one firm. Let's just put up here the characteristics of this type of market. And the first one is that there's a single firm. There's going to be one good, clearly, because there's one firm. And let's say here that there are no close substitutes for this good. And then the final characteristic is that there are strict barriers to entry. Strict barriers to entry. So there are things that keep firms from entering the market. So if you think about where this fits in, you've seen this before most likely. We've talked about perfect competition, and now we're going to think about the other end of the spectrum, and that is monopoly, where there's no competition, a single firm with no competition. The other two types of markets that we're going to think about in the class are going to be monopolistic competition, and we'll think about oligopoly. But for now, we're going to go all the way to this end, and we're going to think about monopoly. Let's start by thinking about some sources of barriers to entry. So you would have talked about these in a Principles of Micro class. So let's kind of list off some of the sources of barriers to entry. Let's start with a natural monopoly. Remember that a natural monopoly is a situation where the average total cost curve is always declining. It's one where we have economies of scale at every at relevant levels of output. Let me describe what I mean by that. Let's say that the cost curve exhibits economies of scale. So let me explain what I mean by that by using an actual cost curve. Let's suppose we had a cost curve that looked like this, 90 plus 20Q. Suppose that was our total cost curve. Let's think about what average total cost would look like. So if we create, remember that this term right here, that's our fixed cost, and this term right there, that's our variable cost. So let's figure out what average total cost looks like. Average total cost is just total cost divided by Q. So average total cost will be 90 over Q plus 20. Now, if we were to graph what this looks like, if I were to graph this average total cost curve, and if we were to put costs up here, and we were to put quantity down here, then we can think about what would happen as quantity goes to 0. Now, I can't divide by 0 here, right? You can't ever divide by 0. But we can think about what happens to this fraction as the denominator goes to 0. As the denominator gets smaller and smaller, the total fraction gets bigger and bigger. And as we increase quantity, the fraction gets smaller and smaller. At a quantity of 1, this term would be 90. At a quantity of 2, it would be 45. At a quantity of 3, it would be 30. So what's happening is this total cost curve, or this average total cost curve, is coming down like this. And as quantity gets bigger and bigger, this term's going to go to 0. And so this average total cost curve gets asymptotic to a horizontal line at 20, right there. So there's what our average total cost curve looks like. As we increase quantity, average total cost is always declining. That's what we mean by economies of scale right there. That total cost curve exhibits economies of scale. That would be an appropriate total cost curve to use for a natural monopoly, something like a public utility, like a water utility. Well, what this means is that there's going to be an incentive for firms to get bigger and bigger and bigger. So any small firm that tried to enter the market would have a very high cost on average. So that can be a very strong barrier to entry, is the shape of the average total cost curve. Another barrier to entry would be switching costs. So what's happening here is that the firm creates a cost for consumers to switch to another firm. So this might be something like a frequent flyer program. So you might think that the airline that you typically fly on, they're doing you a favor by giving you frequent flyer miles that you can use to get free flights in the future. The reality of it is that that's a real effective way to keep your customers from switching to another airlines, is to give them frequent flyer miles. It tricks them into feeling that sunk cost fallacy, where you think, oh boy, I can't switch to another airline because then I would be giving up all of those miles that I've accumulated. So that can be an effective barrier to entry, is creating switching costs for your customers. Another way that firms do this is to bundle. Insurance companies do this. They bundle all of your things into one big insurance package, and that makes it hard for you to switch. If you find a better auto insurance deal someplace else, then you've got to worry about breaking the bundle up and what that means, and a lot of people will just say, you know what, I'm not even going to worry about it. I'm just going to stick with what I've got. Well, what they're doing is creating a barrier to entry. There are the ones that you would have talked about in a principles of micro class. So if a single firm owns all of a key input, single firm owns all of a key input. So the classic examples here, you've heard them before, De Beers Diamonds, or when Alcoa owned all of the bauxite and they were the only company that could make aluminum because you have to have bauxite to make aluminum. And since they owned all the bauxite, nobody else could compete against them in the aluminum market. And then another barrier to entry would be government regulation. So this would be, for example, a patent or a copyright. So the government sometimes creates a situation where a firm has market power by granting them a patent. And in a principles class, you would have talked about a situation, or you probably would have talked about why a firm does this. We know that monopoly is going to create deadweight loss. So you might ask, well, why would the government create a monopoly if it's going to create deadweight loss, which is bad for society? And the answer is that there needs to be some reward to being innovative. And so the government grants patents that are going to reward a company that comes up with a new pharmaceutical drug that a lot of people want to buy. The problem is that once they create it, they're going to have market power, and they're going to use that market power to drive the price up. And then that creates kind of a dilemma for us. We don't like it when they do that, but we want them to have the incentive to be productive. So that's an active discussion, is how do we create the incentive for them to be productive? And is there a way that we can avoid the deadweight loss of that market power at the end? Let me also add one here that normally I talk about and I forgot, and that is what we call network externalities. That can be a very effective barrier to entry. A network externality is when a a firm has a network that other firms wouldn't, that a new firm wouldn't. Kind of a classic example would be a dating site. So let's suppose I was going to create a new dating site. I was going to call it, I don't know, economistsonly.com. And so I invite all of my economics students to join up with my new dating site. And one of the questions you would probably have is, well, how many people are on the site? And I would have to say, well, nobody yet. You're going to be the first one, but we're hoping to grow quickly. Well, think about how useless the dating site is going to be if it's just you and a few other people. So that prohibits, or it doesn't prohibit, it can be a very effective barrier to entry for the firms that already have the network. If you're a dating site that already has 5 million people that are signed up, then it's going to be hard for new firms to enter that market because they don't have any network. So network externalities, that can be a pretty effective barrier to entry. So that gives you an idea of some of the barriers to entry. Let's talk about how a monopoly maximizes profit. It's good to be the monopoly. You don't have any competition, but remember that any monopoly is limited by the consumer's willingness to pay. And the consumer's willingness to pay is shown by the height of the inverse demand curve. And so if you're a monopoly, but you're selling something that nobody wants to buy, well, you're probably not going to do very well. On the other hand, if you're a monopoly and you're the only seller of something that lots of people want to buy, that's a good situation to be in. So the key is that the monopoly faces the market demand curve. Monopoly faces market demand. The monopoly is the only type of firm that faces the market demand curve. No other firm faces the market demand curve. The only way that you face the market demand curve is if every buyer has to buy from you. And clearly that only happens when there's one buyer. So let's think about what marginal revenue looks like for a monopoly. And you've seen this in your Principles of Micro class. In fact, I think I recommended this back in the Perfect Competition chapter. But it would probably be a good idea if you want a quick review on what monopoly is like. Go back to the video that I put together for my Econ 1011 class, my Principles of Micro class. And you can find that on my YouTube page, and you can watch me go through a principles level discussion of monopoly. But that would be probably a good thing to do. We're going to review quickly all of that, and then we're going to add some other things. So let's think about, first we're going to think about what we call a single price monopoly. So this is going to be a situation where you have a monopoly that charges only one price. Okay? The way we're going to do it is we're going to think about kind of what total revenue looks like and then what marginal revenue looks like. Let's just review quickly. Let's think about a demand curve that looks like this, 0 up to 5. And let's put our prices 6 going down by $1 each time, down to 1. If we were to draw that market demand curve, it would look like this. This is going to be an inverse demand curve. So at a price of 6, quantities equal to 0, so our choke price is $6, and it goes down by $1 each time. And by the time we get down at a price of $1, which would be right down here, the quantity's 5. So it actually comes down and hits at 6. I didn't put the last entry into the table, but that's what it would look like. So this would be a nice, simple, inverse demand curve that would look like this. P is equal to 6 minus Q. Very simple. Let's figure out our total revenue. Total revenue is just price times quantity, so it's going to be 0,58985. There's total revenue. Our marginal revenue is just the change in total revenue, so we're not going to figure it out for a level of output of 0. We're going to think about going from 0 to 1, and our total revenue goes from 0 to 5, so the marginal revenue of the first unit is 5, and then from 5 to 8, marginal revenue is 3, and then from 8 to 9, marginal revenue is 1. And you can see that what's happening is it's -1 and then -3. It's going down by $2 each time. Okay? And the key here is that if you graph this thing out, you know that if we look at the marginal revenue for the first unit, it's 5. That would be right in here. And for the second unit, it's 3. That's going to be right down here. You know that the marginal revenue looks like this. There's marginal revenue. For a monopoly, for a downward sloping demand curve, the marginal revenue has the same intercept as the demand curve, as the inverse demand curve, and twice the slope as the inverse demand curve. So if we were to use that information to take this demand curve, there's our demand curve. If we wanted to get the marginal revenue curve, it would look like this. Marginal revenue is equal to 6 minus 2q. Has the same intercept and twice the slope. This is really the key to solving problems in this chapter, is to be able to figure out what the marginal revenue curve looks like. And then what we're going to do is we're going to set marginal revenue equal to marginal cost. Okay, so for any inverse demand curve that I give you, let's suppose I give you one that is 100 minus q over 2. There's an inverse demand curve, a little more complicated than this one, but not much. Your marginal revenue curve, and you might be confused at first as to why I'm writing price and why I'm writing marginal revenue. Don't be confused. Price is denominated in dollars and marginal revenue is denominated in dollars. This is like what we did in our perfect competition chapter where we had marginal cost. It's denominated in dollars. So our marginal revenue curve has the same intercept, so its intercept will be 100, and then it's going to have twice the slope. Well, the slope of this thing is -1/2. And if I take twice that, 2 times -1/2, that turns into just -1. So my slope of my marginal revenue curve is going to be -1. So here's my demand curve, inverse demand. Here's my marginal revenue curve. And again, that's the key to solving these problems, is to be able to take the demand curve that I give you and come up with the marginal revenue curve, because the first thing that we're going to do is set marginal revenue equal to marginal cost. So now let's talk about profit maximization for a monopoly. So I'm going to clear this off and then we'll review what the picture of profit maximization looks like. So a monopoly is going to, just like every other firm, they're going to produce the quantity where marginal revenue equals marginal cost. And I probably said this in the perfect competition chapter. I'll say it again. I'll say it again in the monopolistic competition chapter. And that is that anytime you're trying to solve a problem that involves a firm trying to decide how much output to produce or what price to charge, the first step to always solving those problems is to figure out where marginal revenue equals marginal cost. It may be a picture where you're looking at the marginal revenue curve and the marginal cost curve. It may be a table where you've got numbers, a table of numbers for marginal revenue and marginal cost, and you need to look where two numbers are equal. It may be two functions where you've got a marginal revenue function and a marginal cost function, and you need to set them equal to each other. But if you're ever stumped and you're not sure what to do, remind yourself you're looking for this. Start there, okay? So if we look at the cost curves for a monopoly, let's put up here the marginal cost curve. Let's just go with that one for now. We don't need an average total cost. Let's put the demand curve that the firm faces. There's the downward sloping demand curve, and now we've got our marginal revenue curve. So the firm is going to look where marginal revenue equals marginal cost, which happens right there. I'm going to call that QM. That's the profit maximizing quantity for the monopoly to produce. And then they're going to get their price from the demand curve. They want to charge the highest price that consumers are willing to pay for that quantity. And remember, the height of the demand curve represents the willingness to pay at the margin. And so there's the price. I'll call it PM for the monopoly price. So we know that that's what the picture looks like for a monopoly. Okay. Let's just go through a quick example where we just do this numerically, and you'll see that solving these monopoly problems is not hard. You just need to use the demand curve that they face to come up with the marginal revenue curve and then set it equal to marginal cost. So let's do an example. Let's suppose I give you a total cost curve that looks like this: 20 plus 3Q plus Q squared over 2. And when you first see that total cost curve, you might think, oh gosh, that's quadratic and that's confusing, and that's fine. You're not going to be setting the total cost curve equal to anything. What's important is the marginal cost curve, and for this total cost curve, the marginal cost curve is just 3 plus Q. It's a nice simple marginal cost curve. So all we have to do is take the derivative of that total cost curve with respect to quantity. So if you know your calculus, you know that the marginal cost is very simple. You don't need to know the calculus. I'm always going to give this to you. But don't be confused by that thing seeming like it's complicated. So there's the marginal cost. Let me give you the demand curve. This is going to be the market demand curve. Q equals 30 minus P. That is the market demand curve. Notice that it is not the inverse demand curve. So you don't want to just all of a sudden graph this thing because you need to make sure that anytime you graph it, you're working with the inverse demand curve. Now the nice thing about this one is that even if you did graph the wrong thing, because I don't have this divided by anything or multiplied by anything, and same with that, it's actually the same curve. So the inverse demand curve is just P equals 30 minus Q. So you would get lucky if you just went ahead and graphed that and labeled it P and Q. The problem would come in if you took this and started trying to figure out the marginal revenue curve and then set that equal to marginal cost. So I'll show you that here in just a second. So we've got the inverse demand curve. That's the one we want to be looking for. What we want to do, step one, is to figure out what marginal revenue looks like. So marginal revenue, same intercept, which is 30, and twice the slope. Slope of that is 1, so this one's going to have a slope of 2Q. Let me just show you how to get that with a little bit of calculus. So I'm going to put this in a box. This is not something that I would ever ask you to do, but for those of you who do know some calculus, and I know some do, let me show you where that comes from. Let me show you why the rule works. If we take our inverse demand curve, P equals 30 minus Q, and we create total revenue. Total revenue is just price times quantity. And so if I take price, which is 30 minus Q, and I multiply it by quantity, I'm going to get 30Q minus Q squared. So that's what total revenue looks like. Total revenue is equal to 30Q minus Q squared. Well, the marginal revenue curve is the derivative of the total revenue curve. So marginal revenue is equal to the derivative of total revenue with respect to quantity. And if we take the derivative of that with respect to quantity, we get 30 minus 2Q. That's where that marginal revenue curve comes from. So you can remember the rule, just take the same slope and twice the intercept, or the same intercept and twice the slope. Or if you want to get fancy, you can actually figure out what total revenue looks like and then take the derivative of that. Both of them get you the exact same answer. So there's our marginal revenue curve. What we need to do is we need to set marginal revenue and marginal cost equal to each other. So when we do that, we get 3 plus Q is equal to 30 minus 2Q. That is marginal cost equal to marginal revenue. So if we manipulate this, we're going to get 3Q is equal to 27. Q is equal to, what is that? 27 divided by 3, 9. Yeah, Q is equal to 9. So that's the first step. Now we need to plug that quantity into our demand curve or the inverse demand curve. I would plug it into the inverse demand curve to get price. So we're going to plug that quantity in. We get P is equal to 30 minus 9. That tells me that P is equal to $21. So this monopoly will produce a quantity of 9 units and charge a price of 21. Now let's think about what that looks like graphically. So if we graph the inverse demand curve, our inverse demand curve has an intercept of 30 and a slope of -1, so it comes down here. It hits also at 30. Since our slope is -1, it goes down 1 over 1. Our marginal revenue curve has an intercept of 30 also, and it comes down here with twice the slope. It actually hits at 15. You could figure that out by plugging in a price, a dollar amount of 0, and you'll get a quantity of 15. Our marginal cost curve has an intercept of 3 and a slope of +1, so it looks like that. There's our marginal cost curve. It's linear. What we did is we set, here's marginal revenue, we set marginal revenue equal to marginal cost right here, and out of that popped a quantity of 9. And then what we did is we plugged that quantity of 9 back into the demand curve, and that gave us a price of $21. So you can see that as long as you're careful and you know the trick for getting your marginal revenue curve, none of this is difficult. You set marginal revenue equal to marginal cost, that gives you the quantity. Plug that quantity back into the demand curve, that gives you the price. Let me demonstrate one thing that I sometimes see students make a mistake on. So what you have to do to get your marginal revenue curve is you have to be working with the inverse demand curve. Let's suppose that I wasn't. Suppose I forgot that I needed to do that and I was working with my demand curve, which looks like this, 30 minus P. Suppose it didn't occur to me that I need to invert that. And so I said, okay, my marginal revenue curve has the same intercept, which is 30, twice the slope. The slope of this is 1, so I'm going to say minus 2P. So there's my marginal revenue curve. And at this point, you probably wouldn't realize that you had made a mistake, but you would quickly realize it when you set marginal revenue equal to marginal cost, because marginal revenue, our marginal cost is 3 plus Q, equal to marginal revenue, which is 30 minus 2P, and then all of a sudden you'd say, wait a second, I've got P over here and I've got Q over there. I can't solve for either of those. I don't know what I'm supposed to do. That's the point at which you realize, okay, I've made a mistake somewhere, and you would need to go back and kind of retrace your steps, and hopefully you would realize that you need to invert that thing to get the marginal revenue curve. Okay? So make sure that you invert it and you're working with that when you start to graph it, when you get your marginal revenue curve. Once you've got this, we could easily figure out what deadweight loss is, what the consumer surplus is, what producer surplus is. There's all kinds of things that we could figure out. One of the things you would need to know is you would probably need to figure out what that point is. But keep in mind, if you know this quantity of 9, you can plug 9 into the marginal revenue curve to figure out what that dollar amount is. You could plug it into the marginal cost curve to figure out what that dollar amount is. Let's do that. Let's take 9, a quantity of 9, and plug it into our marginal cost curve. Well, if we plug a Q of 9 in there, it's going to be 9 plus 3. This is $12 right there. Same thing if we plugged a Q of 9 into the marginal revenue curve. We would get the same thing. So now, once you've got that number, you could figure out all of this stuff. You would probably need to figure out that intersection if you wanted to calculate deadweight loss. But the way that you figure out that intersection, that's where the marginal cost curve and the demand curve intersect. So just set marginal cost equal to the demand curve, which is, I would set it equal to the inverse demand curve. And that'll give you this quantity, and it would give you that price. So once you kind of know what's going on here, solving these problems is not challenging. Let's talk about what's known as the markup formula. It's also known as the learner index. So we're going to think about the markup formula or the learner index, named after an economist, not surprisingly named Lerner. Notice something that you would have learned already in a Principles of Micro class is that a monopoly ends up charging a price that's higher than their marginal cost. If we go back to this picture and we look at this quantity and we want to know the marginal cost of that quantity, we go up to the marginal cost curve and we hit it right here. There would be marginal cost. And we see that the firm, the monopoly, charges a price that is greater than marginal cost. So we call that the markup over marginal cost. A monopoly charges you a price that's greater than their cost of production. We can see it right here. The monopoly charges a price of $21, but the marginal cost of producing 9 units is only $12. They mark up this good $9 over their marginal cost. We can use the markup formula to figure out how much they can mark up the good. So here's how the markup formula works. Here's the learner index. Price minus marginal cost, divided by P. Price minus marginal cost divided by P is equal to 1 over, and then we're going to put a negative sign out here, 1 over the elasticity of demand. So notice that this is the percent of the firm's price that is the markup. So this price minus marginal cost would be this distance right here. In this case, it would be $9. And then we divide that by the price, which would be 21. So it's telling us in percentage terms, how big is this markup? What percentage of the total price is this markup? And it turns out that it's equal to 1 over the inverse, or it's equal to 1 over the elasticity of demand, or the inverse of the elasticity of demand. Okay? So the more elastic demand is, the smaller the markup. In other words, the flatter the demand curve is, the smaller the markup is. Okay? So if you know the elasticity, you can easily figure out what percentage of the firm's price would be the markup. Notice that as that demand curve becomes flatter, the markup goes down, and if the demand curve were to become perfectly elastic, like it would be for a perfectly competitive firm, then the markup would be 0. As the elasticity goes up, as the denominator gets bigger, this whole fraction goes to 0. So for a perfectly competitive firm, they don't have the ability to mark up the good at all. Their markup is 0. They just charge the market price, and for a perfectly competitive firm, price equals marginal cost. There is no markup. Okay, so one thing that I see students get a little bit confused about in this class is that they see this markup formula or the learner index, and they think that somehow this is a new way to calculate elasticity. It is not. This is a way to take the elasticity and figure out how much the firm can mark up its price. Okay? If I were to give you price and marginal cost, you could calculate the third thing over here, which is the elasticity of demand. But typically what's going to happen is you're going to know the elasticity of demand. you take the inverse of it, and that tells you how much the firm can mark up their price. Okay? What we want to do now is we want to think about the effect of a monopoly on consumer and producer surplus. So what I need to do is clear this off, and then we'll take a look at that. Let's take a look at consumer and producer surplus with the monopoly. And what I'm going to do with this monopoly picture is I'm going to kind of simplify it by making my marginal cost be constant. And I'll explain what that means here in a second. But let's start out with a constant marginal cost. That really is just a simplifying assumption. It doesn't really change much at all. I'll actually show you what this picture looks like with a rising marginal cost. But let's put our demand curve in here and the marginal revenue curve. Let's go ahead and identify the quantity that the firm is going to produce. There's our quantity for the monopoly. They're going to charge this price right up here. You know how to figure those out mathematically. If I were to give you the demand curve or the inverse demand curve, you could get the marginal revenue. You could set it equal to marginal cost. In this case, the functional form for the marginal cost curve would just look something like this. It would just be a number, whatever that number is. Marginal cost equals 10. So it would be simple. It's not a function. It's just marginal cost is equal to 10. It doesn't matter if the quantity's here or quantity's there or the quantity's out there. It's always equal to 10. Okay? So ignore that for now because we're just going to be highlighting some areas up here. Consumer surplus, remember, is the area under the demand curve and above the price. So consumer surplus is this triangle right up here. Let's shade it in like this. There's consumer surplus. The deadweight loss of monopoly is this area right out here, deadweight loss. And then producer surplus is this, in this picture, it's a rectangle, so this is producer surplus. I'll shade it in like that. So producer surplus is all of that. So you can see that, especially in that picture, it's still just a matter of calculating some areas of triangles and a rectangle. Let me show you let's do a smaller version of what it would look like with a rising marginal cost. You've seen it before. Here's our marginal cost. Here's the demand curve. Here's the marginal revenue curve. The quantity is right here. The price is right up there. Our consumer surplus is this area. Producer surplus is this area. And that triangle right there is our deadweight loss. So, again, triangles and rectangles you're calculating the area of. Let's take a look now at how monopoly and perfect competition compare to each other in terms of consumer surplus and producer surplus and deadweight loss, and how they compare in terms of the price and quantity. So what I want to do here is I'm going to draw a picture of a perfectly competitive market. So this is a competitive market, not a firm, but the entire market. And then here I'll draw a picture of a monopoly. And this is also a picture of the entire market. Because remember, a monopoly, there's only one firm. So if I'm drawing the picture of the firm for a monopoly, it is the market. So here's Q, here's P, Q. Let's draw our market demand curve over here. There's our demand curve. And let's draw the same market demand curve over here. There's our demand curve. Let's draw our marginal cost curve in each picture. Now, over in this picture, the marginal cost curve would also be the supply curve. We would label it S as a supply curve. Over here, we would not label it S, but it would still be the marginal cost curve. So it would look the same in each picture. Now, let's start with our picture of our perfectly competitive market. In this case, the market we know would go to that intersection. This would be the market price. We've been calling that P star. This would be Q star. over in this picture, with the monopoly picture, we know that the monopoly is not going to look where demand and marginal cost intersect. It's going to look where marginal revenue and marginal cost intersect. So the monopoly will produce this quantity, what we call QM, and they will charge this price, what we call PM. Now, if you look at that picture, I tried to draw it so that my demand and marginal cost curves were about the same, and that allows us to compare the price in each market and the quantity in each market. What we see is that the monopoly uses its market power to restrict quantity. This would be the perfectly competitive quantity right there that corresponds to the intersection. But what we see is that the monopoly produces a smaller quantity than that. And the price that would exist in a perfectly competitive market would be this price right here. Corresponds to the intersection of my demand curve and marginal cost curve. But the monopoly charges a higher price. So we know that the monopoly uses its market power to restrict quantity and drive price up into this inelastic portion of the demand curve. And what that does is it allows it to make more profit than if it charged any other price or produced any other quantity. Now, in this picture, we know that this area is consumer surplus, this is producer surplus, and deadweight loss is equal to 0. In this picture, our consumer surplus is smaller, so having a monopoly in the market causes a consumer surplus loss. Producer surplus is this area, it's this kind of trapezoid area right in here, and then that is going to be our deadweight loss. So now this allows us to see that the monopoly using its market power creates deadweight loss for society. Now, the monopoly is not doing anything wrong, right? From the monopoly's perspective, they're doing everything right. They should be maximizing their profit. But from society's viewpoint, it creates deadweight loss. Okay? Now, in terms of how to do this comparison, we can also do this with a constant marginal cost. And I believe that your book does this comparison with constant marginal cost. So let's do that. Let's just take a quick look with a couple of small pictures here at what that would look like. I'm going to draw the same demand curve. This is going to be my perfectly competitive market. So here's my competitive market. Here's my monopoly. Let's suppose we have constant marginal cost in both of them. So if my marginal cost is constant, here's demand. My marginal cost curve would be the supply curve in a competitive market. It would be constant. Over here we would just call it marginal cost. So if we wanted to identify the quantity that would exist in a competitive market, our quantity would be right there, what we'll call Q star. And our price would be right there. And of course, price equals marginal cost, just like we would expect it to. But over here, the monopoly is going to look where marginal revenue equals marginal cost. So they're going to produce this quantity, QM, and they're going to charge this price, PM. And so we can see, especially in these pictures, we can see that the monopoly uses its market power to restrict quantity. This would be the free market, the perfectly competitive quantity, and it restricts quantity back to here. And instead of charging a price equal to marginal cost, it charges this price. It marks it up. And if we knew the elasticity of the demand curve at this point right here, we could figure out exactly how much they mark it up. Of course, if we solved for the price and the marginal cost, we could also directly calculate the percentage of the full price that is the markup. In this particular situation, here's consumer surplus. Producer surplus in a competitive market with constant marginal cost, producer surplus would be equal to 0. But there's no deadweight loss. In this picture, consumer surplus is up here, deadweight loss is right there, and producer surplus is right there. So you can see that the areas look a little bit different when we've got a constant marginal cost than what they look like when we've got an upward sloping marginal cost, but everything is is still pretty much working the same way. What we want to do now is clear this off, and then we'll finish up by talking about some government regulation in regards to the deadweight loss of monopoly. Because the monopoly creates deadweight loss, the government may have an incentive to step in and try to fix that deadweight loss. Remember, we talked just a little bit ago about the fact that sometimes the government creates monopoly. Well, sometimes they also, even when they don't create monopoly, they have an incentive to step in and try to fix the deadweight loss that is created by a monopoly. And so let's talk about some things that they could do. Price regulation is one that we need to talk about. So they may force the monopoly to charge a price other than the price that it wants to charge. This is actually fairly common with natural monopolies. Common with natural monopoly. Now let's think about what's going on there. If we have a natural monopoly, remember a natural monopoly is a situation where the average total cost is always declining. In fact, if we were to draw a picture of a natural monopoly, here's what it would look like. A natural monopoly is a situation where marginal cost is constant. So we have a constant marginal cost, and then we have a declining average total cost. We saw earlier a function that would give us an average total cost that looks like this. So there's what our cost curves look like for a natural monopoly. Let's put in here the demand curve. I'm going to extend this up, and let's suppose the demand curve looks like this. I shouldn't have taken that down into the negative quadrant down there, so ignore that little part of it. I need to draw my marginal revenue curve. This one does go negative, so there's my marginal revenue curve. The firm's going to look where marginal revenue and marginal cost are equal, which happens right there. There's quantity. And they're going to charge this price right up here. There's our price. So with no regulation, the monopoly would charge this price of P and it would produce that quantity. If this was perfect competition, then the quantity that would be produced would be right out here. I'm going to call it P star, because that's what we've always called it when we're talking about perfect competition. As a matter of fact, let's put an M here for the monopoly quantity and the monopoly price. If this was perfect competition, the price would be down there, price equals marginal cost. All right? So let's think about the problems that would happen if the government forces the monopoly to, say, charge a price equal to marginal cost. So suppose the government forces the monopoly to charge a price equal to marginal cost. Well, there's obviously going to be a big problem with that. If the monopoly is regulated to charge a price equal to marginal cost, then notice that its price at every quantity is going to be below its average total cost. And so price is less than average total cost in that case, which means that profit is less than zero, which means this firm will exit in the long run. Firm exits. Let's say in the long run. So in order for the government to make sure this firm did not exit in the long run, the government would have to subsidize the firm. So if they regulate the firm and force them to charge a price equal to marginal cost, then if the government doesn't do something, the firm will exit the market. And there are lots of examples historically, worldwide, where governments have imposed this type of regulation and then the firm exits. Maybe it's a bus system that exits the market. And so then the government's left with the bus system, no bus system, and they have to figure out what to do from that point on. It could be the case that the government allows the firm to just charge a price equal to their average total cost. so that they could charge this price equal to average total cost. If we think about what's going on there, the problem with that is that only the firm knows actually what its average total costs are. So if the government says, okay, we'll let you produce whatever quantity you want, but we're always going to charge you a price equal to your average total cost, then the firm has every incentive to exaggerate what its average total cost is. The other problem is, so if price is set to equal average total cost, the firm has an incentive to exaggerate its average total cost. So the firm exaggerates average total cost. The other problem is that the firm has no incentive whatsoever to actually be responsible with its costs. So no incentive to reduce costs. As a matter of fact, the firm has every incentive to just let whatever happens to its average total costs happen, because the government is always going to allow it to charge a price equal to its average total cost, so there's no use to go through the effort to try to keep your costs in check. If you just don't even worry about it, then the government's always going to allow you to charge a price equal to that. Very similar to the types of problems we see in a government-owned business like the Postal Service. Very little incentive to reduce costs because the government's always going to cover their losses anyway. So that's one thing. The government can impose some regulation. There are some other things. There are certainly antitrust laws. And those antitrust laws allow the Justice Department, allow the government to prevent mergers. It allows the government to break companies up. Now, the Justice Department can't just decide that it wants to do that. It has to argue its case before a federal judge. But if the judge agrees with the Justice Department, then the Justice Department can break the company up. This is what happened to Bell Telephone back when it was broken up into what came to be known as the Baby Bells. There's also clearly a ban on collusion. So if firms get caught colluding with each other, they will get in trouble with the Justice Department. So they can impose regulation. There are antitrust laws that are in effect. There's also another thing that they can do, and that is to do nothing. That's one possibility, and there are probably a lot of situations where most economists would argue that the government probably should do nothing, and that the reason there is that government failure can often impose costs that are bigger than the deadweight loss they're trying to fix. So if we were to look at this picture, if we ignore these things right here and we just focus on the monopoly doing what it wants to do to maximize profit, then this area over here would be the deadweight loss created by the monopoly. And so the government may be wanting to try to step in to either decrease that deadweight loss or eliminate it altogether. And so the government may choose to step in and do something, but the problem is that the government failure oftentimes outweighs the deadweight loss they're trying to fix. Sometimes one of the things I didn't list right here is that the government can take the monopoly over. That's the case of the U.S. Postal Service. So the problem with that is that within the government there is a lack of accountability. Politicians are not held accountable for the impacts of the laws that they pass. Typically, by the time the impacts of any laws are passed, those politicians are out of office, or even if they're still in office, they can just argue that it was, I don't know, corporations doing it, it was some other politician on the other side of the aisle, it was their policy that created this problem. So that creates, that lack of accountability creates a situation where within those organizations that are run by the government, when the government takes them over, there's no incentive to reduce costs or to try to keep those costs in check. It just creates a problem. So many economists would argue that even though there may be a role to try to decrease the deadweight loss of monopoly, oftentimes probably it's better if the government doesn't do anything. That's not to say that the government should never do anything. We're not saying that. It's just that we have to be selective about when the government can effectively step in and reduce the deadweight loss. In terms of working problems in this with these types of monopoly problems, remember that the formula is simple. You're always setting marginal revenue equal to marginal cost. Once you've done that, out of that will pop the quantity that the firm is going to produce. Once you've got the quantity, plug it into the demand curve, and that will give you the price that they're going to charge. Once you've got the price and the quantity, you can figure out things like profit. You would never need to worry about how many firms there are in the market because there's only one firm in a monopoly. And we don't need to worry about the difference between the short run and the long run, because if a monopoly makes a positive profit in the short run, they can continue to make that profit in the long run because there's no entry. One thing I didn't mention in this video, but I'm counting on you remembering it from your principles class, is that the monopoly has no supply curve. And what we mean by that is that there's no single curve on the picture that we could label as a supply curve. The monopoly still makes a supply decision. They still choose the quantity to produce, but we can't label anything as a supply curve. But in terms of working problems in this chapter, it's very straightforward. You're always just looking where marginal revenue equals marginal cost. And the trick is going to be to use that inverse demand curve to get your marginal revenue. What we'll do in future videos is we'll talk about how monopolistic competition works, which you hopefully remember is graphically exactly the same as monopoly. We're also going to take a look at how oligopoly works. So in that chapter, we're going to be thinking about different models of oligopoly. We'll talk about some game theory stuff, but we'll also work through a couple of different models of oligopoly that you probably haven't seen before. So I'll see you in a future video.